So again, we said that the carbon atom, it contains protons positive, electrons negative, and neutrons that have no charge. In the nucleus of the atom, you can see protons that are positive. Here they are, 6 protons positive, 6 neutrons that have no charge. We colored them with green. Hang on a second, please. Okay, let's continue. Now, you have, write with me, please. You have positive 6 protons. You have negative 6 electrons. So the total charge of the atom is 0. So what we say now is that the atom contains 6 positive charges, 6 negative charges that cancel each other. So the atom charge is neutral. Means that it has no charge. Why? Because always the number of protons equals the number of electrons. Okay, this is what we are going to speak now, to speak about now. I need someone to read. Please raise your hands. Raise your hands. Omar Ahmed.
Yes, hello, Mr.
Hello. Read please with me. In 1932,
In 1932, English scientist named James Chadwick shows that another particle exists in the nucleus of atoms. This particle, called a neutron, was hard to find because it has no electron charge. Scientists have learned more about the atom since then. One modern model of the atom is shown in Figure 7. At the center of atom is a tiny, dense nucleus containing proton and neutron surrounding the nucleus. Surrounding the nucleus is a cloud-like region of moving electrons. Most of
Stop. So this is the figure we are speaking about. The dense center of the atom is the nucleus. The nucleus contains protons positive, and neutrons that have no charge. And around the nucleus, you can see this cloud where the electrons are moving around the nucleus. Continue.
Can you go up? Yes, most of an atom's volume is the space in which the electrons move. This space is huge compared to the space taken up by the nucleus. Image holding a pencil while standing in the middle of a stadium. If the nucleus were the size of a pencil eraser, the electrons would reach as far away as the top row of seats. New research support the modern model of the atom. However, scientists still don't know the details of the smart scales of matter. Who will develop the next model of the matter? Maybe it will be you.
Maybe it will be you, inshallah. Thank you very much.
Ya Rab.
Now, what are the masses of the atom and the charges in the atom? As you see here, hang on a second. We won't miss the part speaking about the charges, as you see here. And I need another one to read. Ahmed El-Mahdi.
Yes.
Particle charge.
Particle charge. In figure 7, protons are shown by plus sign. Electrons are shown by
Why is
the
the sign
symbol
positive? So the protons, look, the protons are positive. Here we go. Continue.
Okay. Electrons are shown by the symbol E.
E
According
negative.
to
Actually,
the
it's E negative, but it's not appearing. Continue.
E negative. According to the scale used for measuring charge in atoms, protons have a charge of positive 1. Electrons have exactly the opposite charge. So electrons have a charge if negative 1. If you count the number of protons in figure 7, you will see there are 6. You will see that there are 6. The number,
yes, we
the
have
number
here,
of
look,
protons.
we have here 6 protons, 1, 2, 3, 4, 5, 6. And also we have here 6 electrons. So always the number of protons equals the number of electrons. So always the positive charge equal the negative charge. Continue.
As a result, the positive charge from the protons equals the negative charge from the electrons. The charge is balanced, making the atom neutral.
Neutral. What is the meaning of neutral? It has no charge. Neutral means it has no charge. Okay?
Neutrons don't affect the charge of an atom, but they have a charge of 0.
Zero. So why didn't we speak about the neutrons? Because the neutrons have a charge of 0. But we have protons positive 1, we have electrons negative 1. Okay? Thank you very much.
Welcome.
Yes, yeah, Susie, look at this. You have, look at this. The 6 negative or 6 electrons negative spinning in the electron cloud. And we have, look, if I took this portion and zoomed on it, now you have 1, 2, 3, 4, 5, 6 also, 6 positive protons. So you have 6 negative electrons and 6 positive, 6 positive protons. Is it clear? Okay. Now to the next one. What about the mass? Which one is larger than the other? Which one has more mass than the other? Is it the protons or the electrons? I need someone to read, please. Omar Tamir. Omar Tamir.
Yes, Mister.
I need to read, please.
Although electrons may balance protons charge for charge, they cannot compare when it comes to mass. It takes almost 1,840 electrons to equal the mass of one proton.
So
A pro-
one proton's mass is equal to 1,840 electrons. So the electrons are much smaller than the protons. Continue.
a proton or neutron and are about equal in mass together.
So again, the
The
electron
proton
is much smaller than the proton, while the proton and the neutrons are equal in mass. Continue together.
together. The protons and neutrons makes up almost all the mass on an atom.
Continue.
Figure 8 compares the charge and masses of their atomic particle. Atoms are too small to be described by everyday units of mass, such as grams or kilograms. Or sometimes scientists use units to know atomic mass unit (AMU).
So the unit of measuring mass, normally we measure mass by gram or kilogram, but because the protons and the neutrons are very small, so we use another unit to measure their mass, which is called atomic mass unit or AMU. Continue.
About one AMU.
Okay, a proton or neutron has the mass equal to about 1 AMU. Susie, read the next one, please. Atomic number. We will stop here today at the atomic number. Read it, please, yeah, Susie.
Mister?
Then we will explain it the next time. Atomic
Okay.
number.
Atomic number. Every atom of an element has the same number of protons. For example, every carbon atom has 6 protons, and every iron atom has 26 protons. The number of protons in the nucleus of an atom is the atomic number of that atom's element. The definition of an element is based on its atomic number. Carbon's atomic number is 6 and iron's is 26.
Okay, great. So now the atomic number is the number of protons. This is the new definition for today. When I'm asking you about the atomic number, it is so the atomic number is the number of protons in the nucleus of an atom.